Assalamualaikum and hi everyone. Okay, we already discussed and go through several examples on error propagation analysis using slope-off method. So now we will continue our lecture still on error propagation in indirect measurement topic but using the slope-off method. Usually, the slope-off method is more preferable compared to slope-off method. This is due to its systematic calculation method, especially when dealing with large number of measurement data, with more than one unknown quantity need to be determined. As I already mentioned in the previous lecture, matrix function will be used in slope-off method in order to analyze the error propagation for the unknown quantity. Take a look at the equation at the bottom of the slide. Summation x here is the variance-covariance matrix of unknown, where, by solving all the matrices in the right side, the standard error of x can be determined. Summation y here is the variance-covariance matrix of observation quantity, where the variance or standard error of the quantity is already known. A is coefficient matrix, where the vector of the matrix can be determined by function derivation. Move on to the first example. This example is actually the same example in slope-off method. However, here we try to solve the problem using slope-off method. Distance x1 and distance x2 were observed, and the distance and its standard error are recorded as shown here. Find the distance and standard deviation for point A to C using slope-off method. Step 1. Create the formula. To find the distance x3, distance x1 plus distance x2, so distance x3 equals to 130.930 meter. How about its standard error? Step 2. Create the variance-covariance matrix of observed quantity. The vector for this matrix is actually the variance of the observed quantity. So, variance-covariance matrix for the observed quantity x1 and x2 is equals to sigma x1 squared, where sigma x1 is equal to 0.012, while sigma x2 is equal to 0.015. The dimension of this matrix will be differ based on the number of observed quantity. In this example, there are only two observed quantity, which is x1 and x2. So, the dimension of the matrix will be 2 by 2. If there are 3 observed quantity, so the matrix 3 by 3 will be created, and if there are 4 observed quantity, the matrix 4 by 4 will be created. Step 3. Create variance-covariance matrix of the function unknown x3. Summation x3 is variance-covariance matrix of x3, which is equal to sigma x3 squared. This unknown that we want to find, which is the standard error of x3. So here, we just leave the matrix to sigma x3 squared and we'll solve it later. The dimension of this matrix is 1 by 1 due to only one unknown, which is x3, need to be determined. If there are 2 or 3 unknown that need to be solved, thus the dimension of the matrix will be 2 by 2 and 3 by 3 respectively. Move on to step 4. Create the coefficient matrix A. This matrix is created based on the differentiation of function created earlier, which is x3 equals to x1 plus x2 with respect to x1 and x2. The dimension of the matrix here is 1 by 2 due to there is only one function and two observed quantity. For example, if there are two functions and three observed quantity, so the matrix dimension will become 2 by 3. Step 5. Combine all the matrices in the form of variance covariance unknown matrix equals to coefficient A matrix times variance covariance observation matrix times A transpose. Write all the matrices that had been created earlier. Step 6. Solve all the matrices. Solving the matrices, we can get the answer variance of the distance x3, which is 3.69 times 10 to the power of negative 4. Square root the variance in order to get the standard error value. So, the standard error for distance x3 is equals to plus minus 0.019 meter. The final distance A to C or x3 is equal to 130.930 meter plus minus 0.019 meter. Okay, so now take a look at the example number 2. As shown in figure, the vertical angle alpha to point B is observed at point A as 3 degree, with sigma alpha being plus minus 1 minute. The slope distance D from A to B is observed as 1000 meter, with sigma D being plus minus 0.05 meter. Compute the horizontal distance and its standard deviation. Now, list out the given data vertical angle 3 degree with standard error equal to plus minus 1 minute, slope distance D with its standard error equal to plus minus 0.05 meter. Step 1. Create the formula to find the horizontal distance h. The horizontal distance can be determined using the equation h equals to d cos alpha. Solve the equation and the horizontal distance h is equal to 998.630 meter. How about the standard deviation or standard error of horizontal distance h? Move on to step 2. Create the variance covariance matrix of observed quantity. In this question, there are two observed quantity, which are the slope distance d and vertical angle alpha. So, the dimension of variance covariance observation matrix that will be created is 2 by 2. The vector for this matrix is actually the variance of the observed quantity. So, variance covariance matrix for the observed quantity d and alpha is equal to 0.05 square and 1 minute or 60 seconds divided by 206,265 square respectively. Here, the second unit needs to be converted to radian in order to make the unit standardized. Please refer on previous video lecture for detailed explanation on why unit second needs to be divided by 206,265. Step 3. Create the variance covariance matrix of the function unknown h. Summation h here is variance covariance matrix of h, which is equal to sigma h squared, where this is the unknown that we want to find, which sigma h is the standard error of horizontal distance h. So here, we just leave the matrix to sigma h squared and we'll solve it later. The dimension of this matrix is 1 by 1, due to only one unknown, which is h, need to be determined. Move on to step 4. Create coefficient matrix. This matrix is created based on the differentiation of function created earlier, which is h equals to d cos alpha. Differentiate with respect to d and alpha. The dimension of the matrix A here is 1 by 2. This is due to there are one function or one unknown and two observed quantity. Step 5. Combine all the matrices created earlier in the form of variance covariance unknown equal to A matrix times variance covariance observation times A transpose. List all the matrices created earlier in the form of equation listed on the top of the slide. Step 6. Solve all the matrices combined in step 5 to get the standard error of horizontal distance h. By solving the matrices, we can get the variance of horizontal distance h, which is 2.72492 times 10 to the power of negative 3. Then, square root the variance in order to get the standard error value. So here, we get the standard error of horizontal distance h, which is equal to plus minus 0.052 meter. Thus, the final horizontal distance h is equal to 998.630 plus minus 0.052 meter. So now, try to solve the example 2 in previous video lecture using the Klopov method. Here, I leave several exercises for you to be solved. That's all for this session, and don't forget to try solving the exercise. Thank you.